Hey everyone, I'm Richie. Thanks for that nice intro. So I'm here to talk to you today about our journey at Dropbox, a case study, if you will, how we've gone from prototype to product, taking that from a couple weeks at a time to down to less than an hour. Unfortunately, Elaine's not here today. My friend and teammate is not able to make it. We did this talk internally in August, and you guys are missing out because there were pirate voices, there were dogs being generated, and I'm just talking today, so it's not as fun. But before I get started, I'll just give a quick intro, and then just talk about the agenda of what I'm going to go over today. Kind of briefly, light discussion around challenges, and then solutions and trade-offs. But I want to focus mostly on the actual case study, which is what we've done. So I think it's no secret, we're all here. AI is moving incredibly fast and is transforming so many industries today. And I think we're in a really lucky place where we get to be a big part of how we put these models into production, how we actually translate this magic into real products and systems. There's a quote, I wish I could remember who it's attributed to, and I'll just paraphrase it, but when there is a gold rush, make shovels. And I think we're kind of shovel makers, a lot of us here. So let's talk about some of the challenges that we face, right? Like, this is not an easy task. There are all kinds of tools built around many different complex problems that we need to solve within our machine learning pipelines. And they're very top of mind, right? Like, we're all trying to learn from each other and what everyone can teach us about how to do this better. But in general, we need to move faster. Things are getting released so quickly. Ever since ChatGPT was released, I think in November of last year, it's just been so much faster than I've ever done in my career in this industry. And if we want to keep up, we need to keep pace with the new things that are being released. And so we want to be wary of vendor lock-in. We want to make sure that we can be agile as we are iterating on the different things that we're using. There are a couple other things that make this difficult too. A lot of ML platforms are pretty similar to like a regular back-end engineering system. But we do face, in my opinion, some unique challenges on serving platforms. So first, not all models are the same, right? Like, there are so many different use cases. Maybe for some, you have a huge 40 billion parameter LLM, and you're kind of expecting it to take a few seconds, and you build that into the expectations and into the product. But you may have something like search suggestions that needs like 5-10 milliseconds at 95th percentile, so it has to be really fast. But the challenge for our platform team is we need to accommodate everyone under that umbrella and make it so their services are reliable. If you've done any iterating on machine learning models, you know that it's never linear. It's always cyclical. There's so many different things that you need to try. You'll go down, it's like the garden of forking paths, where you go, maybe I turn right, I have to back up and go left and try something else. You need to keep track of versioning automatically. And that's not always easy to do at scale. Resource allocation is very top of mind right now with these really nice, really powerful models that require enormous compute capacity. So you need to make sure that you're planning for this correctly before you are sending it out into the wild into your products. So you need to be careful with this. And last, there are tons of challenges. This is the last one I'll go over. But there are a lot of great tools that work individually for a specific task. They're great for training, or maybe it's great for deployment, but it's not always something that's easy to glue them all together and get them to work well cohesively. So, quick solutions and trade-offs discussion here. I'm not going to get too far into the weeds here, but I wanted us to ask ourselves some questions. Where are you today? I think it's important to be honest. As software companies, we need to develop iteratively, and you may find something really shiny and exciting, but that doesn't mean that you're ready for it yet. And so you need to start from where you are today. What advantages do you have? Maybe you have awesome infrastructure. Maybe you have a lot of expertise with a tool that's beloved by all of your users. But you got to think about what's available today, like what you can leverage. On the other side of that coin, what are your bottlenecks? That's why I'm here. I'm here to learn, how is everyone else solving the problems that we have, so we can learn and figure out how we can break down bottlenecks and make efficient systems. So one proposal that I think really works well for us is integrating with open source. As you do this, there are definitely a few basic questions to ask yourself. So licensing, for example, you need to make sure that it's legal to use this and distribute in the way that you need to for your system. Operational burden, honestly, this one is the hardest part of open source, in my opinion. You don't know how much extra work this is going to cause you to integrate it into your existing system. And so you need to be really careful thinking about how much work it is to bring something new in. And similarly, leverage. Are you able to leverage those things that are going well for you and roll that into this new system you want to bring in? So that takes me to our case study. I'm going to talk a little bit about what we've done, give a small amount of context about kind of our team and what we do, and then go through one of our recent cycles from survey to making some improvements. So at Dropbox, we have quite a few users. We have 700 million. Last time I Googled it, so correct me if I'm wrong. But that introduces some unique scaling challenges for us. We need to make sure that these services are reliable under incredible amounts of load sometimes. And so to that effect, we've run over 15,000 experiments internally in order to find some of the best models that can work for our users today. And that leaves us with about 150 plus in production. This is from my talk in August. We've definitely added a lot more given the stuff I'm going to be going over here in a bit. But this is just to give you an idea of some of the scale that we're looking at. So you may be thinking, why does Dropbox use AI? They're a file sharing company. What are they even going to do? Dropbox Dash is something I'm super excited about, and I wish I could share the really cool YouTube ad that we have for it that explains really well what it does. But essentially, it's universal search that organizes all of your content, even outside of Dropbox. And so it makes it really easy to focus on doing your best work without having to do a lot of work about work. Dropbox AI, I think, is probably most people's best guess when they would think of what does Dropbox use AI for. This is another really cool thing where you can ask actual natural language questions in your search bar and get a summary of an answer with a source to go along with it if you want to go verify for yourself. And then Dropbox Studio, we do have video editing software that we're working with as well. Some of the models we use for this, so audio transcription or image segmentation, we can't take all the credit. This is an amazing product, but we do provide the infrastructure for these incredible models that go into these products. So with that, you may be wondering, what does our stack look like? And this is obviously a gross oversimplification in terms of the linearity of what's going on. But we handle everything in the process between prototyping, gathering data, ETL, development, and actual inference. It's kind of a mix between stuff that we've built in-house along with open source and third-party tools. This is as of 2022, by the way, just a snapshot to give some context. There may be some things you recognize here, like Jupyter Hub, Spark, Airflow, S3. The main deployment and inference service that we had was built entirely in-house. Excuse me. And so first, before I go further, I need to acknowledge there is a ton of infrastructure advantages that we have. As a mature software company, we've been around for a bit. We have teams that manage our Kubernetes clusters. We have mature CI/CD pipelines, auto alerting, all of this in place, teams to support our orchestration. So we took that and we wanted to leverage all of these advantages into something that could make us faster in terms of prototyping and deploying. So every 6 months, we send out a survey to our end users, so different product teams, ML engineers, data scientists, and we ask them how it's going. So 2 things I really want to highlight here is the prototyping and the deployment part. 26% of our respondents said that it took them over 2 weeks to prototype with our tools. And with deployment, the service we built in-house, it took over 2 weeks for 47% of our users. And granted, there may be a little bit of wiggle room there in terms of like maybe they're counting their entire process, iterating over and over. But as folks who work with this day to day, we understand where they're coming from. There are definite issues that we can improve. And at the same time, we also noticed that our users were really happy with our support. We're very active on Slack. So much so, it may be to a fault, that our users think, well, if it doesn't work, I'll just reach out to MLPlat. And so recognizing this, we were thinking, why don't we just kill 2 birds with 1 stone? And we'll make it more self-serve so that it's faster and that they can self-serve. So this is an actual quote that I found in the survey. Sometimes when I want to prototype, it's faster to do it on my own without relying on ML platform. Yeah, that stung a little bit. It's obviously okay if they want to use their own thing to make it work, but if they're avoiding it entirely, I think something's wrong. So we decided to make some changes. We need to move faster. So quick shout out to some of the open source products that we love. I'm not going to go over all of these today. And granted, there are like as many open source projects as there are sands at the beach. Pick which one, you know what I mean? Like there's a lot to choose from, but we love these ones. And in the interest of time, I'm just gonna be talking about Kserve and Hugging Face. I'll give a sec if you want to take any pictures. So I'm gonna be talking more about the serving stack in this talk. Kserve is awesome. It's a serving platform for your machine learning models, and Hugging Face is a lot of different things. You can train, deploy as well in Hugging Face, but we use it mostly for the third-party models that are available. And I'm going to dig into a little bit what these do for us in a bit. So Kserve, I apologize, this is probably not super easy to read, but this is one I'm personally really excited about. I work a lot with the inference layer of our platform. And from someone who's come from working on something we've built in-house with all of the legacy, with all of the tech debt, all of the support that goes into it, it's really exciting to see something that works so well out of the box. All of the major frameworks are supported here in terms of like model formats, so like TensorFlow, PyTorch, Onyx, some of the ones we use a lot at Dropbox. These are all available runtimes right out of the box, which is super exciting. But I do need to point out, this is built on top of Kubernetes. And so I know a lot of us have kind of a love-hate relationship with Kubernetes sometimes. It can be tricky. But because we had this infrastructure already built in, we decided to roll with Kserve. So I think a lot of the benefit in Kserve comes a lot down to the runtime that you choose. This is not an exhaustive list, but when I'm talking about runtimes here, I'm talking about essentially different Docker containers that are optimized for specific frameworks, as well as different serving platforms. So like TorchServe is great for PyTorch. TF serving is great for TensorFlow. Triton Inference Server is something from NVIDIA that we're super excited about that can support multiple platforms. Personally, we have been using the custom Kserve model server a lot. It gives you a little more control if you want to write different code. Integrating with our own infrastructure was a lot easier to do it quickly. So there are a lot of different runtimes you can choose. I highly recommend checking out Kserve's website to see what some of the options are. And so it makes it really easy to iterate. It's very config-based. And so rather than writing a lot of boilerplate code and getting that approved, getting tests, you can just push it and that it will deploy as a custom resource, CRD, custom resource. I'm not remembering the D. Anyway. Okay, moving on. Hugging Face. As I said previously, we use this a lot for third-party models. One of the things I love about Hugging Face is it's so clearly spelled out. If you want to include a model that you found in Hugging Face and there is a good license for it, there's not a lot of extra code you have to write. So these lines, don't worry about being able to actually read this. It's not super relevant. But I wanted to highlight that the lines that are highlighted in green, these are all the lines I had to write in order to host this chatbot from Facebook. And we built some tools to generate the boilerplate around this if you want to have like your own tests or something. But essentially, this is it. This is really easy to get up and running. And with generalized models that can input like text, images, very generic kind of formats, these are really easy to spin up. But at the same time, we need glue. We have all these moving parts. We need to get it to work together. And so I wanted to go briefly through some of the things that we've done to glue these open source projects together to improve our iteration speeds. We have this model file downloader that will pull the models from Hugging Face and put it directly into our secure model store. We have deployment config tools that make it really easy to abstract away the hairier details about what your config should actually look like. This is in the form of YAML files. And so we have linters that make sure it's correct. We have different libraries for our users to generate config on their own. And as well as enriching this with Dropbox metadata to make sure that it plays nicely with our infrastructure. The secret syncer is something that I think is really valuable in this pipeline as well. In order to have security best practices, we need to make sure that these credentials used in Kubernetes to pull images and model files are locked down and they're short term. So we have the secret syncer daemon that will periodically sync secrets pretty quickly in order to reduce the attack surface. The deployment service we've made is really great for gating models that actually go to production. Our users are free to use their own namespace if they want to prototype models in Kubernetes. But when it comes time to the real world where we're getting to production, we do need to provide a little bit of extra security gating to make sure not just anything gets out. And I don't have it on this deck, but we do also use image scanning from Artifactory to make sure there are no vulnerabilities that we push out as well. And then once these are approved with a PR, they get deployed automatically. All right, so now that we're getting models into production, we want to make sure that they are high quality and that they're able to handle the load that we're giving them. And so we've built several tools around quality and observability. So for example, this benchmarking service is a recent one that we've built where we can use standardized data sets to make sure in real time that the models that we're considering are valid and that they are the quality that they say they are before we put them into production. As we all know, user trust is incredibly important, so we want to make sure that we're sending out quality, validating that quality before we send it out. We build load testing tools. We found that if we're able to determine and replicate prod traffic before sending something out with a specific auto-scaling config, we're able to plan ahead for the resources instead of just hoping for the best and then on-call kind of handles things. And along that same front, the observability. Folks need to know how fast things are. They need to know how much memory is being used. They need to know even like debugging logs. They want to be able to see this stuff. And then tied into that is the alerting aspect. So we want to make sure that if anything goes wrong, the right team is notified, and so we can have a quick time to resolution. So at the end of all of this integration, we added a few more things in bold. So you'll see Kserve in a couple different spots. It's used for both prototyping and for inference. And we've also built on top of Kserve generic machine learning APIs that our engineering teams can use without any ML experience. But if they want to use something that is intelligent without having to worry about deploying a model, they're welcome to use APIs right out of the box. Same with our LLM stack. We've built this on top of Kubernetes, on top of Kserve. And we're unable to, I'm unable to go a whole lot into depth. Sorry, Garrett's getting paged. Anyway, I'm unable to go a whole lot into the LLM stack in this talk. But if you want to talk to us later, we're welcome to talk a little bit about our LLM stack. I didn't go over Kubeflow a lot in this talk, but it's another one I'm super excited about. It's really, really great for iterative pipelines, for training and tuning and other things of that nature. So at the end of the day, we made all these great things, but do our users actually like them? Does it actually provide any value for them? Thankfully, we made things way faster. So the entire cycle from prototyping to deployment, we were able to reduce from weeks down to less than an hour. And a lot of this is waiting on Kserve to orchestrate resources and to spin up all the pods and everything, pull down the model files. But especially with the third-party models, it's really easy for us to go on Hugging Face, for example, and think like, well, I found this really cool embeddings model. Let me go test it out and just spin it up. And that's it. There's no weeks of waiting. There's no writing all this boilerplate for it. It just works really well out of the box. And even though this did take a little bit of extra time with support up front, our users are now able to be a lot more self-serve when it comes to using this platform. So to kind of wrap things up here, I think in general, a lot of us are on many different stages of this journey of building a great platform. Even just from talking with folks today, I think it's really cool to learn from you all because there are so many different things that we're doing well and so many different things that we can collaborate on. And I'm excited for the future. So takeaways, if nothing else, AI is accelerating. It's probably not going to stop accelerating for a while. And if you want to accelerate with it, you need to improve iteratively. And that means asking for feedback and improving on that feedback and then going back to your users to make sure it's working the way you want it to. And lastly, I would just say consider open source. It's worked well for us. If you haven't started using open source yet, you don't have to build it yourself. There's a lot of great things out there. Thank you.
Thank you, Richie. So we have time for some questions. Please raise your hands if you have questions, and a mic will come to you.
I'm Fabian with MongoDB. My question comes with, you mentioned Hugging Face, you mentioned open source models, and you mentioned some relative success with what you guys did internally. I'm wondering, what you haven't necessarily specified is what model did you end up using out of all of the open source models? Or like what, and why, essentially, right? Like, was it Claude? Was it New Hope? Was it, whichever one of the new open source models is? Because there's a bunch of them, and it's really hard to tell which ones are correct for what, right? So, just curious.
Yeah, that's a good question. We have a lot of different use cases, so it's not just one. So we have like specific areas that we want to improve. So like text embedding is one that we think about a lot with files, and so we've iterated on a couple of these. So mini-LM, GTE large, there's a lot that you can find. I guess my point is like it's specific to like the use case you need it for.
So maybe I'll reframe the question, right? The reason why I asked the question is because, like, in my experiments, I ended up with GPT-4 because I don't understand enough of what's going on under the hood of all these open source LLMs to make a super, business critical decision on this type of stuff. So I went with like, look, I'll just use GPT-4. There's a lot of things to be learned here. This is definitely going to change. But that's why I was kind of asking the question. I understand there's a bunch of different use cases, right? And for example, if we want to touch about the different use cases, then like for large text summarization, for like large pieces of text, say the Bible, say a book, say anything, right? Like what models would you recommend based on the experience? Because like in Dropbox, I assume you're building, and this is my reverse engineer mind kicking in, right? But essentially you're probably doing a profile on each one of the users and gathering all that data from what they're doing, maybe analyzing the type of requests that they're doing, and then organizing their workflow based on what they do, essentially. But this could be a very large amount of data, right? So how do you turn, you know what I mean? The question's about the models, but that's the problem that I'm trying to solve. Like very large amounts of data that don't fit into a context window of a typical model that's open source.
Yeah, no, that's a good question. I think, so first specifically with large language models, we're big fans of Llama. Am I allowed to say that? Llama is it's open source from Meta. We have a couple different variants of it. And we kind of try to find the sweet spot between quality and inference speed. So like the 7 billion parameter one, 13 billion parameter one, those are pretty popular. There are different things you can do to make it faster too if you have a lot of data. But in general, I would advise to stay away from just going directly to LLMs for a lot of problems because they are so compute intensive. There are a lot simpler models that can solve tasks without having all of the compute overhead with it. But yeah, if you're talking specifically about LLMs, we really like Llama.
On the LLMs, and this is a very biased question, it's very personally biased, right? But it's about, forget the LLM, forget like whether or not it's Llama, or like when we're talking about large pieces of text, what ends up happening is inevitably chunking, chunk size, chunk overlap, fitting into context windows, et cetera, right? So like, how do you, how are you approaching that problem? And it's just me trying to pick your brain. Yeah. You don't
no
have
worries.
to answer, honestly.
Yeah, like you said, obviously there's a limit to the amount of context you can put to a model, right? I think one approach that we've seen a lot is compressing to vectors, like embedded vectors first, and then doing computation on top of that. And so you may have some kind of semantic search first, and then when you find the relevant piece from that document, then you can send that to an LLM. Yep.
The question?
Okay, Richie, unfortunately we are out of time. Maybe one more question. Yeah, go ahead.
Oh, can you share a super short version of your MLOps journey prior to 2022? What prompted you guys to custom build all these components in-house?
Yeah, open source, in our experience, wasn't entirely mature yet, and so we had a lot of bespoke solutions for like individual problems. So there's some overlap with like actual backend services that got split out. But I think there were some that were pretty solid, like Jupyter Hub's been solid for a long time. But yeah, just a lot of like bespoke, trying to figure things out, piece it together. But through that, we get a lot of the battle scars that make it so we know what to do the next time.